All right, guys. So this is going to go with worksheet 65A. 65A. That's worksheet 65A. I don't know if you can see that because this stand, I can't see what I'm actually filming right now. I just know it fits. Okay, so we're going to go back to derivatives, which you guys like a little bit more. So we're going to do what's called a first derivative test and the second derivative test. And this is kind of a chart to show you. So we have f of x up here, and then we have f prime of x, and then f double prime of x. And so this right here would be considered the first derivative test. So this chart right here is the first derivative test. This is the second derivative test, and we'll get to that later. So that's the second derivative test. And so on this worksheet, we're going to talk about what the first derivative test tells us. And you already know a few things about it. So with the first derivative, derivate, let's finish that one out. There we go, derivative. When we take the derivative, that's what this means here. We set it equal to 0. We find a maximum or we find a minimum. Now, we do that. We can say if it's an absolute maximum or it's an absolute minimum or a relative maximum or a relative minimum, and we'll get to those here in a minute, by knowing if the first derivative goes from a positive to a negative at this point, or it goes from a negative to a positive at this point. We also know that f of x is increasing, going up, if f prime is greater than 0. We also know it's decreasing if f prime is less than 0. And then these are called inflection points. These inflection points are when you go from a positive to a positive or a negative to a negative. And they have to do with our second derivative test and then concavity going like it's a cup or it's a cup down. So we'll talk about that a little bit later. So let's just tackle this piece here. So if we go f prime of x, and I'll do it in a different color for you guys. I may do it. There we go. Here's blue right here. I don't know if you guys can see the difference on this camera. So let's just talk about f prime of x. Take the derivative. 3, subtract 1, 1, subtract 1, and then the constant disappears. So that's my derivative. Now, if I set that equal to 0, I get 3 times x squared minus 4, and then therefore it's x is plus 2 or minus, x is minus 2, right? And then therefore I get negative 2 and positive 2. So these are called critical values. So we're going to call these CVs, or critical values. Now what we do with the critical values is this. We take a number line. It's called a sign chart. And you'll see these. So this is a sign chart of f prime. So my 2 points are negative 2 and 2. So all we do is this. I really wish I had my red pen. Oh well. All we do is this. I got a green one. Let's see if this one works. We don't worry about these actual critical values. So I know that these two values are going to be a maximum or a minimum because that's where the value is set equal to 0. I just need to know if it's a max or a min. So we take this sign chart, and it's kind of literally, so this is an f prime sign chart. And I take the next available number or an easy number on this side. So if I take, let's just take negative 3. If I plug in negative 3 here, I get negative 3 squared, which is 9. 9 times 3 is 27. 27 minus 12 is 15. So that is a positive value. I'm going to take 0 because it's really easy to work with. So if I plug in 0 here, that kills it, and we get a negative 12. So the signs in between these two are going to all be negative. And then I go over here to 3, And I look at this and go, okay, well, plug in 3, I get 27 minus 12, that's 15, that's positive. So we know a couple of things. We know that this is a critical value. So now I have a critical value, x equals -2, and I go from a positive to a negative, positive to a negative is a maximum. And I also know that I go from a negative to a positive here at x equals 2, and that is a minimum because I go from a negative to a positive. All right, now, the only other thing we need to do here is we need to find out the points. So I need to know the y value, so I need to evaluate this thing at f of -2. Not f prime, f of -2. So if I take -2 and I plug it in here, I get -2 cubed plus, nope, not plus, minus 12 times -2 minus 5. So then I get -8 and plus 24 minus 5. And so then I get -13, so this is 11. So at -2 and 11, I have a maximum. I do the same thing for my minimum here, and I'm going to take 2 and I'm going to plug it in, so I get 2 cubed, so f of 2. Sorry if it's small, guys. I need to learn a little bit better how to deal with this. F of 2, and if I plug that in, that's 2 cubed. Remember, we're going back into the original one up here. Minus 2, and 2 minus 5. Remember, this should be a negative number because it's down here. That's what it's saying, it's negative. So I'm going to go like this, and it looks like this is 8 minus 24 minus 5. So at f of 2, I get -29, so -21. So my point is 2 and -21, and that's a minimum. So I've got those pieces here. All right, so now, and I know that this is positive here, so that means it's going to be increasing because it's greater than 0, right? This is going to be negative, so it's going to be coming down from here. And then it's going to be positive, so it's going to be going back up and increasing. So let's take f now, and you can do this on your calculator. Take f and put it in your calculator, and you get f of x minus 12x minus 5, right? And we get our f of x, which is our y, and this is our x. And if I look at this, I'll just graph my critical points. I end up with -2 and 11, -2, and I'll go up here to 11, -2 and 11. And I will take 2 and 21, 2 and -21. So I come way down here, and I go to 2 and -21, because that's my minimum. This is my maximum. And then I'm greater than 0 here, so if I'm coming up from the left, I know that it's a positive here. As I hit this, I become a maximum, so that means I'm going to turn and go down somewhere like this. And that's for my negative right here. It's decreasing because it's negative. And then the final piece is, I know I go back, and I go back to increasing. So let's just kind of draw some things in here. We know that this blue line, f prime, is greater than 0. It's positive. We know that this piece here, f prime, is less than 0, so it's negative. And we know that this right here is f prime is greater than 0 because it's increasing. Now, I've got to decide whether these are Relative maximum and minimums are absolute. If they're absolute, they'll be the top point of the graph no matter what. And if you notice, these keep going off for here forever and down here forever. So it's getting a little crowded. I know that this is a relative maximum, not an absolute. We'll tackle that on the next one. And I will have this as a relative minimum because it still goes down farther over here. Now, if I stop this thing here and then I stop it here, this becomes an absolute maximum because it doesn't go any higher than this, and this becomes a relative minimum. So it depends on how, if these are the absolute top and bottom of the graph, and you can have opposite things where if this keeps going, this is a relative minimum, but this is an absolute maximum. So the first derivative test tells us a couple different things. It tells us our critical values, and our critical values on a first derivative test tell us our maximum and minimum. Our sign chart, where we plug in the critical values back into the first derivative, tells us if it's increasing or decreasing. Increasing is greater than 0 or positive. Decreasing is less than 0 or negative. And then once we go from a positive to a negative, we know that it's a maximum, and we got to look at the graph to see if it's an absolute or a relative maximum, and the same thing for a minimum. So that's our video on 65A, guys, and I'll do another one for the second derivative test.